Here's an interesting subject I'd like to cover as it relates to long distance shooting, particularly precision shooting. So as you've seen in previous posts, I've dove off the deep end in the manufacturing of my own rounds. It first started with 9mm. Now it's up to my true passion, which is long range precision shooting. And I had a homie I talked with that asked me about S.D. on a story that I post, and that S.D. stands for Standard Deviation. So back in the day, shooters used to measure a disbursement of data by means of extreme spread, but that has since taken backseat to standard deviation. So just a quick tip on what standard deviation means. If you have a means, let's say you have a cartridge speed that is about 2,400 feet per second. That is your means. That's the data that you're trying to accomplish. Anything above or anything below is a disbursement of that data. So you're going to use your means as a baseline, and you're going to add up all of those means, and then you do some calculations, which I can get off into the deep end. It's a lot of math that's involved with it. But basically, if you're taking a 5-shot string, you're going to do some mathematics. You're going to add up that 5-shot string, and then you're going to divide it, the sum of that number, by 5. And then there's some deeper calculations you have to square root, and you have to use various other types of math that it'll take me a 45-minute video to explain. So if you want to shortcut that, here's the ticket. Get a Garmin Xero. You can get this over at brownells.com. Make sure you put code BOP10 in to save you some coin. So the importance of utilizing a chronograph to see what your standard deviation is. Let's go down to history. So I'll press OK, and then I'll look at, so I've done 5-shot strings. I have a target over here that I'll discuss from a previous session. But we'll go into this 5-shot string. Now, I've conducted a few tests with some different loads. So here, if you can make this out on screen, this is a 5-shot string from some data that I captured. I actually bumped my powder weight up to 35.5. Now, I am going to give a disclaimer to tell you this information is for me only. You should follow the guidelines and the various reloading manuals out there for your own safety. So I'm using the Sierra Match King bullet, 140 grains. And I started off this load at 35 grains of powder, H380. And then I wanted to test this, which I'm conducting a ladder test. I bumped this up to 35.5. And this is the group. So the gun is sighted in. I'm shooting at just different areas on the paper. I was aiming for this square. And you can see there's a lateral movement in the group. When I bumped up from 35 to 35.5, my standard deviation, if you can see, was at 35.1. You want your standard deviation to be in single digits, and I'll explain why. So I'll back out of this and go to my first session. That was actually the last session. I'm going to show the first session of today and look at the history. And you can see here the standard deviation is 8.7, and that's this group. So this group is much tighter, even though the weapon is sighted in. That's probably a little over a ½ inch, maybe 3/4 of an inch. This is definitely about probably a little over an 1/8 of an inch. The group being tight, the gun is sighted in. That's not necessarily my worry. The reason why that standard deviation is so important to me and why this Garmin chronograph helps with that, once you start getting beyond 500 yards, you're shooting very long distances. And typically a rifle such as this G8 Precision that I'm shooting, that's a 1,000-yard rifle. I'm shooting 6.5 Creedmoor. The reason behind standard deviation is there is no more of a variance of 8.7 feet per second between my 5-shot string, which my mean here is 2450 and no 2400, I'm sorry. And I'm only deviating 8.7 feet above or below 2400 feet per second. The reason that's important is because once you start to shoot long range or extreme long range, you have to exacerbate the feet per second that you're above your means, which is here 2400. And at 1,000 yards, that's the difference between you shooting way above your target, way left or way right of your target, or shooting a couple feet in front of your target. And you can miscalculate, especially at 1,000 yards. You will be under the impression that it's the wind that's making your rounds deviate. But actually, when you calculate, let's say 30 feet per second standard deviation, and you multiply that over 1,000 yards, that can be just roughly, now the math may not be correct, but that could be something as simple as being 20 yards short of your target. So these numbers actually matter, absolutely matter. So it is always advisable to get your standard deviation in the single digits. Your weapon can absolutely group very tight groups, but you're probably sighting your weapon in at 100 yards. Let me give you an example of this. This is from a range trip a couple of days ago. This group is at 0.448 of an inch, but the standard deviation on this was 25. This group is a little bit bigger than the previous group, but my standard deviation is at 8.7. So this is a more favorable group, and it's a more repeatable load. And this load is going to carry true at extremely long distances. So a simple fix is to repeat this recipe. I could simply bump my Xero up to hit the center of this bullseye, which it is 0. I was just aiming at a lower spot. But let's say this load and that single digit deviation has me just below the bullseye. This is a more desirable group, and it's just simple mathematics just to bump my sight up to 0 it here, and this will outperform this group all day at extreme distances. The only way you can calculate that is to have a chronograph. Now, there's old chronographs like Lab Radar. There's other chronographs out there. I particularly like Garmin, one, because of the support that they have, the customer service that they have. They stand behind their products, and this tool is absolutely accurate. So with that being said, now I can scrap this load in 6.5 at 35.5 grains of powder and stick with just the 35 grains, which is it's slower, but it's much more consistent. And consistency is the name of the game when it comes to long distance shooting. So I am here to absolutely vouch for this Garmin Xero. You can get it over at brownells.com. If you want to be more effective at long range shooting, there's a lot of variables that you have to account for. And having a chronograph is one of the things that can take care of a multitude of the variables that you're going to deal with. Standard deviation, that's something that you definitely want to pay attention to. A quick reference, if you have single digits, 10 is probably the highest you want to go, but if you can get 9 or below in the standard deviation, those rounds are going to fly consistent. They're going to have consistent feet per second. Those consistencies in your feet per second translate to downrange accuracy. If you have a round that's flying 30 feet per second slower or faster than the rest of that group, those turn into what you think are flyers. And actually, they're not flyers. The rounds are just not having the same output when you take that variance in feet per second and multiply it by the distance that you're shooting, or do the equation by the distance that you're shooting. So every 30 feet per second that is off, you have to exacerbate that from 0 to 1,000 yards. And that can very well equate to a bullet hitting the ground 20 yards in front of the target, or a bullet flying 3 feet over or to the left or the right of the target. So that's the importance behind standard deviation. And the only way you can calculate that is by having a chronograph. Once you take that chronograph and you acquire the single digit standard deviation that you're looking for, you then correlate that over to the loads that you're making and the loads that you cook up that's giving you the lowest amount of standard deviation. You can now turn that into rinse and repeat and crank out hundreds of this same round until you find a different setup that you want to use. So for me, the Sierra Match King Starline Brass, Winchester Primer, and the Hodgdon H380 is the system that I'm going with at 35 grains of powder. That works for me out of my rifle. I'm going to rinse and repeat, and that's all based off having the calculations from this Garmin Xero giving me what I need to look for. So that's a tech tip. Sorry I was long-winded, but I just wanted to dive into why I calculate this data. So as always, stay safe, stay trained, get out on the range.